Hi and welcome. So this week, before we get started, I have a few stickers to add to the board. One from Vaughn Industrial, and that's Tom Utley, and he makes brass machine plates, reproductions, etched and painted. They are absolutely stunning, look as good if not better than the originals. So you should check it out. And the other one is from Aaron Engineering down in Australia, and he has a YouTube channel, actually has several it looks like, and we'll be adding those stickers to my collection up here on the garage wall. And so we will pop those up and then we'll start this week's project. And the project this time around is a customer project, and it's sort of pedestrian. It's to take this brass piece and reduce the diameter of this raised boss here and reduce it by about 30 thousandths, if I remember right. But what's going to make it challenging is holding it. And I thought of several methods. One would be to run a shaft all the way through it, thread something on the other side and hold it down. That would work. But more interesting is to match these threads on this side and have this screw against an arbor right up against a flat surface and use that instead. And what makes this interesting is that these threads are M10 by 0.5 millimeter per thread. And 0.5 millimeter threads are really fine threads. Most threading tools, the standard A60 ones, won't thread something that fine. They stop at 48 threads per inch. This is approximately 51 threads per inch, like 50.8 threads per inch. So I'm going to try and see if I can thread this. I might not succeed because I've never threaded anything that fine, and there's probably some special techniques you need to use, but we're going to give it a shot. What this is from is kind of interesting. If you play guitar, electric guitar, you almost certainly heard of Floyd Rose, the Tremelo company. So apparently, the gentleman who owns this company, Sophia, Tremelos, has gotten really good reviews on the tremolos on his guitar. Now, I have been out of playing guitar for a long time, and I've got to admit that I was more of a hack than anything. I've never really was a particularly good guitar player. But I was familiar with Floyd Rose. I haven't heard of his company before, and originally I didn't want to do multi-part, sort of assembly line projects again. This is still a small quantity, relatively speaking, but the gentleman was so nice that I found it really hard to say no. So these parts here allow people who own a Floyd Rose tremolo, like this, to use his dive bar, whammy bar, tremolo bar on his. Apparently, the design of this and the shape is preferred by a lot of Floyd Rose guitar players. So even though they don't have his tremolo system, they still want to use his whammy bar. The difference is that his system uses a D cutout for this brass piece that you saw there, and the Floyd Rose does not have a D cutout. In addition, the Floyd Rose is a larger diameter than his. So, I'm sorry, a smaller diameter than his. So I will be reducing that brass reliefed edge there by, like I said earlier, about 30 thousandths, and they will lose most of the D shape at the same time, which will make it an interrupted cut. And it will be going right up to an edge, which will make it a bit challenging. But the more interesting part to me is figuring out how to mount this. And I also could have screwed it in this way. But this edge right here is a good reference point, so I can just screw this in flush, provided I can pull off these threads. In order to cut those threads, I'm going to use this thread cutting tool. And one caveat is I'm not sure that this is even qualified for threads that small, but I think it is. So we're going to try and use it and see if it'll make an adequate set of threads for me to screw these parts into so that I can machine them down. This is a Micro 100. It's an XN10330, and I bought them off eBay. I got like a half dozen of these for a really good price, but I can't find them on the Micro 100 website, and so far they haven't been able to give me information about these inserts, so I'm not sure if they're qualified. The normal threading inserts that you commonly see, like this guy, don't have a sharp enough point to go down this small. And actually this one's damaged, so this one's toast. But these typically only go down to, I think, 48 TPI max, even when they're fully sharp like that undamaged one right in there. So this will be interesting. All right, so since these threads don't actually show up as any metric standard, the finest pitch for a standard M10 is 0.75. I have to go to a different formula, and I'm going to take the major diameter being 10 for 10 millimeters. And so what I want is know the hole I need to bore out or drill in this thing for the minor pitch diameter, which is your basic major diameter, which is 10 millimeters. And so you go with 10 millimeters, and then you subtract 0.6495191 times the pitch, which shows up in table 3, which is just a list of pitches among other things. So that's 0.5 millimeters per thread. And so I subtract that from 10, and then you add the tolerance, basically, addition for the pitch. So it's either 0 or 0.02. So I'm going to go halfway between those two tolerances. Let's go 0.01 and add it. So that gives me 9.685240045, and I'm going to divide that by 25.4, which is 0.3813. And that gives me the hole size I need to bore out for the minor diameter in English units or US units. And so I'm translating the metric to US units. I do have some metric drills, but I don't have anything close enough to this, I don't think. I probably have a 9.7, but that would be too large. And I have a 9.6, and that would be too small. So instead, we're going to bore it. And rather than have to switch all my units over, or all my measuring equipment over to metric, I'm just going to do it in English units with the translation, which should be more than adequate. As you can see, this part, I just had a piece of steel that had a hole drilled in it already. As you can see, that it was already faced once before, but I need to make sure this face is perpendicular to the axis, so I will be facing it again here. I only need a couple of threads, a very shallow set of threads, but I want some clearance behind the threads, so while I'm threading, since I can't disengage the half nut, at least not without paying attention to my threading dial very carefully, I'm going to put a fair amount of relief behind it. So we bored this to 381.5, but because this is cold rolled steel, the finish sucks. And my concern is that the grooves might be a significant portion of the thread, since the threads are so darn small. I'm not quite sure how to approach this. I got to think some more about it. I might want to switch materials. I was thinking about using brass, but I thought that wouldn't be a good choice because brass might be too soft and have some welding issues, but I don't know. Now I'm going to relieve the back side, and I just need to go in about 15 thousandths. That'll give my threading bar somewhere to go. And that gives me about 2/10 of an inch of thread area. And I need to just slightly chamfer the inside edge here. And then we're going to try and thread this. I have this thing set to do metric threads now. And you can see I burnished the area, the 200 thousandths area that I want the threads to work on. And I've got my settings right, but thread gauges at this small are going to be pretty hard to make work. So I'm just going to go for it. So I pulled it out, I'm reversing the threads. And I think the total depth I need to go in is just 10 thousandths total. So we're just going to try another couple passes here. That was 7 thousandths. Now we're going to reverse, go out, come back, walk into 10 thousandths. I'm going to come back and do another spring pass, see if any material gets cut off. You might have a better view than I do because the camera is kind of in my way. I guess I'm going to see if the threads will start, or if we need to come in a little farther. I am just going straight in, not 30 degrees. That should be enough room for my part to fit. The threads look about right. Oh, look at that. 10 thousandths was right on the money. I calculated it and it worked out. So that's pretty great. So we threaded our parts. So now we've got our tool made. So we can just go and cut a few of these now. Oh, looks like this worked out pretty well. I'm totally surprised. The threads fit nicely. They're a little bit looser. So I guess 10 thousandths is a little bit more for a tight fit, or I actually don't know how tight the other side was done. I'm sure it was done on a CNC machine, and I'm not sure how they did those threads, but I think this is pretty good. We've got a mandrel now, so next step is just to set up these parts to remove a little bit of material and take them down to the final diameter. The hard part was doing these tiny metric threads, and they're a little tough to start, so I may use the threading tool here just to clean up the edge a little bit. But other than that, I think they're really good. You're hearing so much noise because it's an interrupted cut. Here's the parts. Let's see if we can install one and see what it looks like. All right, so here's the Floyd Rose Tremelo. Here's the standard Sophia, and you will see that when I take this off, this is the bottom nut, which is very creative because besides being a larger internal diameter to hold the nylon in place, the nylon bushing, it has been broached with a hex. That is a nice detail. So take the nylon off. First of all, you can see that, oh, that's the washer too that came with the Sophia. So you can see that this doesn't fit, right? That's the part I was reducing the material. So let me unscrew the other side so we can get this out. That has a nylon conical section that pushes in here that sets the tension on the unit. So we'll tighten this guy up. Well, you can make it totally locked too. That's kind of neat. All right. As I recall, the Floyd rose I had just spun freely. There was no tension adjust. So I made this washer. I don't know how thick it should be, but we'll put it on here anyways. There we go. And so there's the Sophia arm on a Floyd Rose tremolo. That's a cool project. I enjoyed it. Making threads this fine was a first for me. That's the equivalent of about 51 TPI in SAE threads, or 0.5 millimeter per thread for metric. And it's an odd size, so I couldn't use a tap and cheat. So took a little bit of effort, but it was very interesting, and so was the whole project. Thanks for watching. Hope you find it useful. Hope to see you next time.